Hey guys, welcome back. This is video 2 in my series on solving other types of equations. And in this video, we're going to look at solving what we call radical equations. So let's jump right in, figure out what those are and how we can figure them out. So what is a radical equation? Well, a radical equation, as you can see here, we have an example, the square root of x equals 9. A radical equation is an equation where the variable is under the square root, or the variable is any higher root. So anything, rather than it being squared or cubed, it's to the 1/2 or the 1/3 or the 1/4. That's what we call radicals, and any equation where we have a variable like that is called a radical equation. Now we can see, how do we solve something like this? Well, if we square both sides, we can think of the square root of x as being x to the 1/2. So when we take the square, remember that with exponents, when we are squaring it like this, that's multiplying. We multiply, so that's like 1/2 times 2, which is 1. So we're just going to get x, and over here, so give us x, and over here we have 9 squared is 81. And we can see that the square root of 81 does in fact equal 9. So that is the correct solution. And that goes into, how do we solve? Well, we're going to raise these radicals to the appropriate reciprocal. So the reciprocal of 1/2 is 2. So in this video, we're just going to be looking at square roots. I believe later on we'll take a look at when we have a 4th root or a cubed root or something like that. But in this video, we're just going to look at square roots, so we'll be squaring them all the time. And that's how we're going to solve. So let's jump right in, look at some examples so that we can get really familiar with this. So our first example is the square root of 20 minus 8x equals x. Now, again, we're going to do just like we did, and we're going to square both sides. Now, as I showed before, when we square this, this is a 1/2 squared. We're just going to get 1, so these cancel each other out. You can think of it as simply as that. And we get 20 minus 8x equals x squared. Well, now, if we move everything to the same side, by adding 8x to both sides and subtracting 20 to both sides, we're going to get x squared plus 8x minus 20 is equal to 0. And now what we have is a quadratic equation. So we've already know how to solve those. If you don't, check out my videos on solving quadratic equations. And what we can do is we can look at the factors of 20, 1 and 20, 2 and 10, and 4 and 5. And we want to know which one of these can we put together to get 8. Well, if we take 10 and subtract 2, we're going to get 8. So we know that we're going to use x and 2 and x and 10. Now, we know that we want to get a positive 8, so we want to subtract 2 from a positive 10. Then this negative times this positive will give us a negative 20 like we want. And we still have equal to 0. So by the zero product property, we have x minus 2 equals 0 and x plus 10 equals 0, which will give us our solutions of x equals 2 and x equals negative 10. Now, if you watched my last video, I was kind of blasé about whether we needed to check it. If our algebra is all correct and you feel comfortable with your algebra, then you don't have to check. It's great to check to make sure you have it right, but if you did all the steps correctly, then 9 out of 10 times you're going to have a correct solution set. But in these equations, we have to check them. And why is that? Well, if we think back to our square root property, when we take the square root of something, we have to consider both the positive and negative. So when we're squaring something, we realize that this could be a negative squared, which would make a positive. And so we have to check to make sure that both of these answers do in fact apply to our equation. So let's do here, and let's look at 20 minus 8x equals x. So let's look at our first solution, which is 2. So we're going to put 2 in for all of our x's. So we have 20 minus 8 times 2 and equals 2. And we're going to see if that's correct. 8 times 2 is 16, and 20 minus 16 is 4. So the square root of 4, does that equal 2? Well, yes, the square root of 4 is 2, and that equals 2. And when we do our square root property, we put a plus or minus in front of the square root. That is not here. We don't have plus or minus the square root of 20 minus 8x. So in fact, they're telling us it's not minus. They're telling us it is the positive square root. If it was the negative square root, we'd have a negative in front of it. So what's important here is that we're only going to be able to have positive answers on this left side because it's a positive square root. So what do you think that means about our other answer, negative 10? Well, let's go ahead and check it out. We have the square root of 20 minus 8 times negative 10, and we want to see, does that equal negative 10? Well, negative 8 times negative 10 is going to give us a positive 80, and 80 plus 20 is going to give us 100. So we have the square root of 100. Oh no, does that equal negative 10? Well, we have the positive square root, so the positive square root of 100 is 10, and that does not equal negative 10, which means even though we did all of our algebra correctly, we got a solution of negative 10. Because of the square roots, this solution is not actually valid in our given equation. So our solution set becomes just 2. So let's always remember that when we are doing these problems, it is very important that we check our answers. Let's go ahead and look at another example. All right, for this one, we have the square root of 6x plus 1 equals x minus 1. So again, we're going to go ahead and start by squaring each side. Now remember, here when we square each side, we can't square x and negative 1 individually. We're squaring the entire quantity. So what that means is that it's not going to be x squared minus 1 squared. It's going to be x minus 1 multiplied by x minus 1. And when we FOIL that out, we can see that we get x squared minus 2x plus 1. So that's what's going to be over here on our right side. X squared minus 2x plus 1. And again, the square and the square root will cancel out, and on this side we'll just get 6x plus 1. Well, now if we move everything to one side, we can see we'll have another quadratic equation. So we'll subtract 6x from both sides, and we'll subtract 1 from both sides, and that'll give us x squared minus 8x, the ones cancel out, and this is all equal to 0. So solving this, just as we solved similar quadratic equations, we can factor out an x, and we get x minus 8. By the zero product property, we get x is equal to 0, and x minus 8 is equal to 0, which gives us x is equal to 8. So again, we have two solutions, and we want to see which of these solutions, or if both of them, actually fit our equation. So we'll go ahead and check it. We have 6 times 0 plus 1 is equal to, doing 0, so 0 minus 1. Well, 6 times 0 is 0 plus 1 is just the square root of 1. And 0 minus 1 is going to give us negative 1. Square root of 1 is 1. 1 does not equal negative 1, so we see that 0 is not one of our solutions. Let's go ahead and check x equals 8. So this time we have the square root of 6 times 8 plus 1. I want to know if that is equal to 8 minus 1. Well, 6 times 8 is 48, and plus 1 is going to give us the square root of 49, and we want to know, does that equal 8 minus 1, which is 7? Yes, square root of 49 is 7, which does in fact equal 7, so our solution set for this one is going to be just 8. Our 0 does not work out when we check it. All right, let's move on to another example. It's going to get a little bit more difficult now. So what happens when we have two radicals? Well, what we want to do is we just want to have one radical on one side, because when we square it, the only way for it to cancel out is if we're just squaring that radical term. So let's add the square root of x minus 2 to both sides. So we're going to get 2x minus 3 is equal to 1 plus the square root of x minus 2. Now we're going to take our step and square both sides. So on this side, the square and the square root are going to cancel out. We're just going to get 2x minus 3. Let's take a look at how we FOIL this right side. So we have 1 plus x minus 2 times 1 plus x minus 2, where x minus 2 is under the square root. So we take our first terms, 1 times 1 is 1. Take our outside terms, 1 times the square root of x minus 2 is just the square root of x minus 2. Our inside terms, this is going to be the same thing, plus square root of x minus 2. And our outside terms is the square root of x minus 2 times the square root of x minus 2, which is the square root of x minus 2 squared, and the squared and the root cancel out. So we're just going to get plus x minus 2. Now remembering, when we have two radicals like this with the same thing, we can add them together, and that's going to give us 2 times the square root of x minus 2. So we have 1 plus that, and then plus x minus 2. Now we can take this 1 and this negative 2, and if we add those together, well, we know that 1 minus negative 2 is negative 1. So let's go ahead and write that over here. So we have equals 2 times the square root of x minus 2. We have plus x, and then doing 1 minus 2, we get minus 1. So let's go ahead and now subtract x from both sides, and at the same time, let's add 1 to both sides. Well, 2x minus x is just going to give us x. Negative 3 plus 1 is going to give us negative 2. We're going to still have the 2 square root of x minus 2 over here, but these both cancel out. Now, what do we do here? Well, we got to get rid of that radical, so we're going to square everything again. So on this left side, we're just going to FOIL it out, and that's going to give us x squared minus 2x is minus 4x, and negative 2 times negative 2 is going to give us plus 4. And on this side, you can think of this as 2 squared, so 2 squared is 4, and then we have the square root of x minus 2 squared. Those will cancel each other out, and we'll just get x minus 2. Remember that 4 is multiplying times both of those, so we're going to have to distribute that. So we'll have x squared minus 4x plus 4 is equal to 4x minus 8, just distributing that 4 to both. Now what we can do is we can go ahead and put everything on the same side, and we'll have a quadratic equation, which is easy to solve. So we're going to subtract 4x from both sides, and we're going to add 8 to both sides. So we have x squared, negative 4x minus 4x is going to give us negative 8x, and 8 plus 4 is going to give us 12 is equal to 0. Now our factors of 12 are 1 and 12, and 2 and 6, and 3 and 4. Well, we can see 2 plus 6 will give us 8, so we know that's what we're going to want to use. So we'll have x and 2 and x and 6. Now, if you have watched my videos on the solving quadratic equations, you know that the rule of signs, when we have a negative and a plus, means that they're both negative. And we can see here that negative 6x minus 2x will give us negative 8x, and negative 2 times negative 6 will give us positive 12. So we have factored this correctly. By the zero product property, we set both equal to 0, and we will get solutions of x is equal to 2 and x is equal to 6. I'm optimistic that both of these solutions will in fact work because they're not negative. And remember, when we have the square root, we're only looking at the positive square root. Those negatives can really throw us off. So let's go ahead and look at I'll write it down here since we don't have very much room to look at our original equation. The square root of 2x minus 3 minus the square root of x minus 2 is equal to 1. So let's start with our solution of 2 and see if we put 2 in for x here, we do in fact get that. So 2 minus 3 minus the square root of 2 minus 2. I want to know, does that equal 1? 2 times 2 is 4. 4 minus 3 is 1. So you have the square root of 1 minus 2 square root of 0. Does that equal 1? Well, the square root of 0 is 0. The square root of 1 is 1. 1 minus 0 does in fact equal 1. And we know that x equals 2 is in fact a solution. Now let's do the same thing with our other possible solution, which is 6. So let's look at 2 times 6 minus 3, all under the square root, minus the square root of 6 minus 2. So 2 times 6 is 12, and 12 minus 3 is 9. So it's going to give us the square root of 9, minus 6 minus 2 is 4, the square root of 4. Square root of 9 is 3, square root of 4 is 2, 3 minus 2 is 1, and does that equal 1? Absolutely. So in this example, our solution set is both of our solutions are valid solutions, and so our solution set is 2 and 6. All right, we're going to look at one more example, and here we have square roots within square roots. So this can look tricky, but we'll see that following the exact same steps, we'll be able to solve this. So we have the square root of 1 plus 4 root x equals 1 plus root x. So let's go ahead and start by squaring it all. Now again, this square is going to cancel with this square root, but not that inner square root. So we need to remember that this is still going to be 1 plus 4 root x. Now over here we have 1 plus root x squared, which is 1 plus root x times 1 plus root x. When we FOIL this out, we get 1 times 1 is 1. And we'll have 2 root x from the outside and inside terms. And then root x times root x is root x squared, which is just x. So we'll get 1 plus 2 root x plus x. Now we can see if we subtract 1 from both sides, that our 1's are going to cancel out. And then if we subtract 2 root x from each side, on the right our 2 root x's will cancel out. 4 root x minus 2 root x is just like we can take the root x out of that, and it's just 4 minus 2, which is going to give us 2, and then multiply that root x right back through, and we get 2 root x. Here, our 1's cancel, our 2 root x's cancel, and we get equal x. So here we still have a root, so let's go ahead and square both sides. Again, 2 root x squared is going to be 2 squared, which is 4, and then root x squared, those are going to cancel out, and you'll get 4x equals x squared. Now we can subtract 4x from each side, and we'll get 0 is equal to x squared minus 4x. We can factor out an x, which gives us x times x minus 4, all equal to 0, which will give us two solutions of x is equal to 0. By the zero product property, we're going to set each equal to 0. X minus 4 is equal to 0 will give us the solution of x is equal to 4. Now again, we need to go back and check and make sure that both of these results work. So we have 0 and 4. Our original equation is the square root of 1 plus 4 root x is equal to 1 plus root x. So first let's put a 0 in here. The square root of 1 plus 4 times the square root of 0 equal to 1 plus the square root of 0. Well, the square root of 0 is 0, and 4 times 0 is 0. So we just have on the left side the square root of 1 plus 0, which is the square root of 1, which is 1. And on the right side we have 1 plus the square root of 0, which is 1 plus 0, which is 1. And we see that 0 is in fact a valid solution. And let's check out 4. Square root of 1 plus 4 times the square root of 4. I want to know, does that equal 1 plus the square root of 4? Square root of 4 is 2, so this is 4 times 2, which is 8, plus 1 is going to give us the square root of 9, which will give us 3. And on the right side, the square root of 4 is 2. 1 plus 2 will give us 3. So in this example also, both 0 and 4, both of our solutions that we found work when we check it in, and so they're both valid solutions, and our solution set is 0 and 4. Thanks so much for watching. This concludes our video on solving radical equations. We're going to move on and continue with our series and solving other types of equations, so I hope that you'll check those out too. Have a great day.